Okay, number 4, we're asked to find the antiderivative, 5 over the quantity 1 minus square root x dx. And so this doesn't immediately strike us as being any of the integration forms we've seen before, so we're going to make a substitution, and we'll let u be the denominator. So if I let u equal this, I can rewrite that as 1 minus x to the 1/2 power. And I'm hoping at some point I'll be able to use this formula that we learned and get it into the form 1 over u du. So let's find what the du is. I take the derivative, I get negative 1/2 x to the minus 1/2 dx, or this is negative 1 over 2x to the 1/2 dx. So I look at my integral and I see what I have, and more importantly what I don't have. I've got 5 over 1 minus square root x dx. So this guy is the u. In order to get the du, I need this. So I'm going to go ahead and write that in there. Now I just can't willy-nilly multiply the inside of this integrand by negative 1 over 2x to the 1/2, because whatever I write here has to be equal to my original integrand. Alright, so what I can do is multiply the inside by the reciprocal of that, 2x to the 1/2 over negative 1. So if I multiply these together, everything cancels out and I'm back to where I started. That now gives me the du. So let's see what this gives me then. This is going to be with the du. I've got this 2 over negative 1. I can bring that out as a negative 2. I can bring the 5 out as well. So I get a negative 10 outside the integral. And then I'm going to have an x to the 1/2 though left over. Like so. So if I take the time and simplify this, I will get back to my original integrand. But now I'm going to take this and turn it into an integral involving u. So it's negative 10 times the integral. The x to the 1/2 I can get from here. If I solve this for x to the 1/2, I get 1 minus u. So I got a 1 minus u up there. The 1 minus square root x is u, and this whole thing is the du. Alright, so now I'm going to go off and integrate this. So negative 10 integral 1 minus u over u du. I can split this up like we did before. I get a 1 over u minus u over u du. So I get negative 10 integral 1 over u du plus 10 integral du. You do that, I get negative 10 natural log absolute value of u plus 10u plus c. Now, as I like to say, you've solved it for u. Now you have to solve it for me. And so I want to know what the x's are. So I go back to my substitution. U is 1 minus the square root of x. And so I get the integral of 5 over 1 minus the square root of x dx is equal to negative 10 natural log absolute value 1 minus square root x plus 10 times the quantity 1 minus square root x plus c. Let's see if we can simplify this at all. Since I don't know what x is and I'm subtracting the square root of x from 1, this quantity could be negative. That means I still need those absolute values. If I multiply the 10 through here, I get 10 minus 10 radical x. Well, that plus 10 can be absorbed into the constant. And so I can rewrite the answer this way. Once again, it's a good exercise to start with this function, take the derivative, simplify, and see if we can get back to the original integrand. That'll do it for number 4. Okay, number 5, we get an integral that's hauntingly similar to number 4. And with all the fun we had in number 4, you might think number 5 is going to be a lot of fun too. Well, it's a little anticlimactic because this is actually a Calc 1 integral. If you rewrite this as the quantity 1 minus x to the 1/2, so we have this, bring it up top, I can move the 5 out front. And what we have in our hands here, folks, is nothing more than a power rule from Calc 1. Now, I'm not going to dignify this with a u substitution, but if you need to, you could let u be 1 minus x, the du be minus dx, and you can go on your merry way. But what's this going to work out to be? I'm basically integrating something to the negative 1/2 power. The result of that is going to be something to the 1/2 power divided by 1/2, which is that something to the 1/2 power times 2. I already have a 5 there, so I'm going to have more or less 10 times 1 minus x to the 1/2 power. And when I take the derivative of this, I'm going to get 5, 1 minus x to the minus 1/2 times a negative 1. So to counteract the negative, I'll put a negative out front, plus c. Okay? So, this is one of the things we're going to learn in Calc 2. These integrands aren't all that different. This took us the better part of 5 minutes to do. This took us the better part of 30 seconds to do. In any case, you can check your answer by taking the derivative, and that's all there is to it. So that'll do it for number 5. Okay, number 6, another indefinite integral. We're looking for the antiderivative of the cotangent of the natural log of x divided by x dx. So once again, this doesn't immediately strike us as any of the forms we've seen before, but we can go to the old adage, we'll let u be the thing in parentheses. So in this case, u here is a natural log of x. That means the du is 1 over x dx. So I can rewrite this. I have a 1 over x dx there. So I can rewrite this as cotangent of natural log x times 1 over x dx. So in the land of u, what do I have? I've got the integral of cotangent of u du. And we know one of the formulas we developed using the natural log was an integration formula for cotangent u. And there's two choices. I'm going to choose natural log absolute value sine of u. Plus c. You've solved it for you, now solve it for me. I want the x's back in there. So this is natural log, the absolute value, the sine of the natural log of x. All right, and what a great exercise in the chain rule to take this, take the derivative, and show you get the integrand cotangent natural log x over x. That'll do it for number 6, and that'll do it for checkpoint quiz 2.